Hello, my dear students and the rest of the learners. Welcome to this presentation in which we shall continue with our discussion on the topic elementary programming principles with examples using Pascal. This is part 3 of a 4-part series of presentations in this topic, and the title of this presentation is Development of Algorithms. My name is Mehmet JM, or you can simply call me EMELISWAP. In this presentation, therefore, we shall define algorithm, discuss data and data structures, talk about writing instructions, look at comparison, selection, and decision statements, which will include structure charts, pseudocodes, flowcharts. Let's commence now by looking at the definition of algorithms. The word algorithm comes from the name of the 19th century Persian mathematician by the name Abdullah Muhammad bin Musa al-Khwarizmi. This word, algorithm, originally referred only to the rules of performing arithmetic using Arabic numerals, but evolved into algorithm by the 18th century. The word has now evolved to include all definite procedures for solving problems or performing tasks. It is a finite set of well-defined instructions for accomplishing some tasks which, given an initial state, will terminate in a corresponding recognizable end state. Algorithms can be implemented by computer programs, although often in restricted forms. Mistakes in implementation and limitations of the computer can prevent a computer program from correctly executing its intended algorithm. Algorithms often have steps that repeat or require decisions, such as logical comparison. Correctly performing an algorithm will not solve a problem if the algorithm is flawed or not appropriate to the problem. Different algorithms may complete the same task with a different set of instructions in more or less time, space, or effort than others. Algorithms are essential to the way computers process information because a computer program is essentially an algorithm that tells the computer what specific steps to perform in what specific order in order to carry out a specific task. Because an algorithm is a precise list of precise steps, the order of computation will almost always be critical to the functioning of an algorithm. Instructions are usually assumed to be listed explicitly and are described as starting from the top and going down to the bottom, an idea that is described more formally by flow of control. The main factors, therefore, that you need to take into account when developing an algorithm are: number one, the data and data structures to be used. Number two, the input, storage, prompting, and output instructions required. Number three is the calculations to be involved. Number four is the data comparisons, selections, and decision statements to be performed. Number five are the tools to be used in developing the algorithm. For example, pseudocodes and flow charts. Let's now look at data and data structures. The efficiency and the clarity of a program always depend heavily on what data structures are used. Data must be organized in a logical and consistent way if it is to be of any use. Data structuring means that we can link individual data items into larger data units that have some further meaning. So, a data structure is an arrangement of data items logically together to give information about an individual. The efficiency of a program is a measure of the amount of resources that are consumed by the program. What are the types of data that our program or our programs can be able to handle? The two fundamental types of data are usually numeric and non-numeric. What is numeric data? This is data that essentially consists of numbers and are divided into two types, that is, integers and real data. The integers are whole numbers used to count things, and they contain no decimals. For example, 743 to 100, etc. While on the other hand, real data is data that has fractional parts or has a decimal point that appears between two digits and can also contain an exponent. Examples include 743.67 minus 0.0345 plus 200.011. In other words, the real data can include whole numbers with decimal points, negative numbers with decimal fractions or with decimal points, as well as positive numbers, but that also contain decimal points. Numeric constants are simply numbers, that is, integers or real, that does not change, but they remain the same during execution of the entire program. It's a constant that represents an integer or a real number. On the other hand, numeric variables are the memory locations that are used to store numbers, which keeps on changing during program execution. It's a variable that stores only numeric data. A variable is therefore a name that is given to represent a piece of data that can be changed or varied while the program is running. While a constant is a value that never changes throughout the course of a running program. Let's now look at non-numeric data. These are character strings, logical values, pointers, and dates. The character strings are sequences of data items of type character. Strings may contain any printable character and are stored as codes using ASCII or EBCDIC code systems. The character strings are a set of characters or text enclosed in a single or double quotation marks. While a string constant is a sequence of characters or text that does not change during the running of a program. A string variable is a sequence of characters that stores any kind of text information because its content keep on changing during the running of the program. The value of a string constant is the characters without quotation marks. Let's now look at the aspect of writing instructions. Program statements are the instructions that are executed by the compiler or interpreter to do whatever the user wants. My dear students and the rest of the learners, if you want to gain much more information about a program statements, you can kindly visit the YouTube channel by the name EMELISWAP ICT and then access part 2 of 4 of this series of presentations that is already posted in that channel by the title Elementary Programming Principles with Examples Using Pascal, part 2 of 4. And from there, you'll be able to understand more about the various program statements and how they are interpreted by the translators. In Pascal, they are separated by semicolons while they are enclosed between begin and end clauses. The statements are also called instructions. The three main classifications of program statements that can be written while coding are: number 1, the input statements. The instructions that are used for reading or accepting data that is entered into the computer by the user from the screen or from a file and store the value in the location with the given variable names are called the input statements. The two types of input statements in Pascal are read and readline. What is read? Read reads data items and assigns them to integer, real, or char type variables while executing the next line on its current line. In other words, read is a keyword that is used in a statement or in an instruction that requests the processor to read data items and assign them to integer, real, or character type variables or memory locations while executing the next line on its current line. Its syntax is int followed by less than sign, then variable name and greater than sign. And remember, every statement in Pascal is terminated using a semicolon. For example, int name. My dear students and the rest of the learners, kindly note the syntax or the way we write or use these key ones. For example, int in a Pascal program. To read several input variables at the same time, you separate them using commas. What about read line? Read line is a keyword that reads data items and assigns them to integer, real, or character type variables while executing the next line or statements on the next new line. Its syntax is read line followed by the variable that is being input and closed in brackets and terminated with a semicolon. For example, read line name. Kindly note the syntax. Let's now look at output statements. These are the instructions that are used to display data that is in the computer's memory on the screen or writing it to an output file. You can output string variables and numeric variables. The two output statements that are usually used in Pascal are write and write line. Let's look at write. This keyword is used to display data items on the screen or output file while the cursor remains on the current line to execute the next statement. Its syntax is write followed by variable name and closed in brackets. But you can write several variables, and just as I have said concerning write, you separate them using commas. For example, write age or write age, comma, name, comma, class. You close the brackets. If you want to display processed data that has already been assigned on a variable, for example, called age during program execution, then you can still use write. An example is write followed by string of characters, e.g., write bracket your age is, then you include the variable name, and then you close the bracket and you terminate the statement with a semicolon. In other words, anything that is enclosed in the quotation mark within a write statement is usually displayed on the screen as it is. So for example, the statement write bracket, your age is, comma, age, closed bracket, then semicolon. When this statement is executed, by the compiler or interpreter, for example, even though in Pascal, we make use of compiler, translator, and not interpreter, then what the compiler will display or what will be displayed on the screen is your age is followed by the value that will be picked from memory location called age. If you just want to display interactive statements to the user that have not been stored on any variable during processing, you can also use write. Let's now look at write line. It is used to display or write data items on the screen or output the file while the cursor moves to the next or new line after the last data item. So, write line executes the subsequent line on a new line and not on the previous or current line. Its syntax is similar to that of write statements. The only difference is that you replace write with write line. And write line is written or coded as WRITELN. Let's now look at processing statements. These are the instructions or statements that manipulate the input data. They involve calculations, that is mathematical operations, repeating instructions, selecting instructions, and comparison instructions. The arithmetic expressions or calculations are those statements that deal with the performance of computational tasks or data. They involve assignment statements, arithmetic operators, relational operators, logical operators, standard number, and character functions. An expression is a statement that is composed of operators and operands that returns a value. Let's look at assignment statements. These assign the results of the expression or data items on the right to whatever variable is on the left. The assignment symbol used is full colon followed by an equal sign in Pascal. This sign, colon and equal sign, is called the assignment operator. The expression must be of the same data type as the variable to which it is being assigned. An assignment is therefore an expression with a value. Its syntax is variable, full colon, equal sign, then expression, or variable, assignment operator, actual calculation. And as usual, every statement or instruction in Pascal is terminated using a semicolon. For example, you can assign the results gotten when you subtract birth year from current year to the variable or memory location called age. I repeat, assign the results of the difference between current year and birth year to the memory location that has been declared and set aside by the name age. In this statement, the variable age is assigned the result of the calculation of current year minus birth year, so that the memory age will hold the result of the calculation that has been performed on the variables current year and birth year. My dear students and the rest of the learners, note that if you have to use two ones to refer to a variable, then you can either join them to become one word, like current year and birth year in this example, or you can separate current year and birth year with underscores. Calculation statements are always written with a variable being assigned the value of a calculation rather than a calculation being assigned a variable. Let's now look at arithmetic operators. These are the symbols that are used to carry out numerical type operations. They include addition, subtraction, multiplication, division, exponent, amongst the others. For example, x raised to y. When several operators are used in the same statement, the compiler follows a certain order of operator precedence. Operator precedence is the order in which an expression is evaluated depending on which calculation is to be done first than the other. So, the order of operator precedence in Pascal is as follows. Number one, or the highest level, is parentheses or brackets, followed by exponent, then multiplication, division, either using forward slash or backslash, mount, addition, or subtraction. Its acronym is therefore PEMDAS. PEMDAS, parentheses, exponent, multiplication, division, addition, then subtraction. My dear students and the rest of the learners, kindly note the symbols or the characters that we use in Pascal programming to present various operations. The other type of operators are called the relational operators. These are special symbols that are used to show relationships or comparison between two or more values representing condition of equality and or inequality and evaluates to true or false. The main relational operators include equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Example is age greater than 28. As usual, just as I have said, my dear students and the rest of the learners, kindly note the symbols that we use to represent each operation. The fourth type of operators are logical, or what we call Boolean operators. These are especially reserved ones used to combine two or more expressions or decisions together to form compound expressions. The four basic Boolean operators used in Pascal are: number one, all. This is an expression which evaluates to true if either operand is true or if both operands are true. In other words, when we use all in a statement, what all does is that it will give a true value if either of the operands is true or if both of them are true. Either condition must be met for the expression to be true or false. The second operator is AND. An expression will be true only if both operands or conditions are true. The AND operator is NOT. This operator is used as a prefix to negate a Boolean operand or the value of a logical expression. The fourth is XOR. It results in a condition that is true if one of the conditions is true and the other is false. That is, expression will be true if either operand is true and false if both operands are either true or false. For example, y greater than 60 and y less than 100. Let's now look at comparison, selection, and decision statements. It sometimes becomes necessary when processing data to compare the values of a variable to the value of another variable, or to compare the value of a variable to that of a constant. In this case, relational operators and Boolean operators may be used to make such comparisons. A condition is an expression that when evaluated gives either a true or a false result. This expression is called a Boolean expression. Those conditions use the relational operators between two variables or between a variable and a constant. Algorithms can therefore be depicted using tools like decision tables, decision trees, structure charts, pseudocodes, and flowcharts. Top-down approach allows a program to be designed methodically by providing a complete definition of the program at each level of complexity. First, the problem statement is specified and the design is subsequently carried out using different techniques such as structure charts, pseudocodes, and flowcharts. Let's look at structure charts. Structure charts show the overall framework of the program, with each level showing progressively more detail. The program is separated into modules, one for each main function. Modules are developed starting from the top and moving down the hierarchy. This method ensures that all modules link in together as the program develops. Structure charts are used mainly to show relationships between program modules and graphically depicts the breakdown of modules. It is often used with other design tools such as pseudocodes and flowcharts to express the process or procedure logic. The following is therefore an example of the design of exam results using structure chart. My dear students and the rest of the learners, you can see from this diagram that when we are using a structure chart, we break down our design into a number of functions. In this diagram, for example, result tabulate is the overall function. Below it, we have three major functions, which are input details, process details, and print report. The major functions are further broken down into other subfunctions, where, for example, the input details function is broken down into two subfunctions, which are validate input and edit input. Then we have the process details function being broken down into calculate subject total, calculate student mean score, calculate mean grade, and calculate comments as subfunctions. Where the major function print report has been broken down into a subfunction, which is print total marks, mean score, mean grade, and the comment. And of course, the subfunctions can further be broken down into subfunctions. For example, the validate input subfunction has been broken down into another subfunction called print errors. So this is what we call a structure chart. It clearly indicates the logic or the structure of all the functions and subfunctions and sub-subfunctions within the program or within the design. Or simply, it illustrates the levels that have to be followed in the development of the algorithm for computing examination results. The other method of developing algorithms is the pseudocode. Pseudocode is a generic way of describing an algorithm using the conventions of programming languages without using language-specific syntax. Pseudocode describes module design in ones using syntax like that of a programming language. It aims at providing programmers with clear and unambiguous process specifications. Process logic in pseudocode is therefore expressed as a combination of sequence of events, decisions that need to be implemented, and actions that they may have to be repeated. Some of the ones used may be drawn directly from a programming language that the designer or the programmer intends to use, and then mixed with the English-like statements from structured statements that are easily understood by non-programmers and also make a lot of sense to programmers. Depending on the writer, pseudocode may vary widely in style, from a near exact imitation of a real programming language at one extreme to a description approaching formatted prose at the other. The main applications of pseudocode, therefore, are Number one, in computer science textbooks, to illustrate examples so that all programmers can understand them, even if they do not all know the same programming language. So, computer science textbooks often use pseudocode in their examples so that all the programmers can understand them, even if they do not all know the same programming languages. Secondly, a programmer who needs to implement a specific algorithm, especially an unfamiliar one, will often start with pseudocode description and then simply translate that description into the target programming language and modify it to interact correctly with the rest of the program. The following are therefore the guidelines that are supposed to be adhered to when deciding or designing a good pseudocode. Number one, the statements must be short, clear, and readable. Number two, the statements must not have more than one meaning. Number three, the pseudocode lines should be clearly outlined and indented clearly. Number four, it should show clearly the start and the stop of executable statements and the control structures involved. Number five, the input, output, and the processing statements should be clearly stated using keywords such as print, read, input, etc. The following are 3 examples to demonstrate how to write a pseudocode. So the following is a pseudocode for a program that can be used to calculate the area and the perimeter of a circle. So the first solution, or the first way of writing such a pseudocode, would be start, set pi to 3.143. Then prompt the user for the radius r, store the radius in a variable r, set the perimeter p to 2 times pi times r, or that is times radius. Then set the area a to pi times radius. Store the perimeter in a variable called p. Then store the area in a variable called a. Then print the value in the variable for perimeter. Print the area and then stop. That's one example of a pseudocode. You can see very clearly, my dear students and the rest of the learners, that a good pseudocode that is readable can easily inform somebody what the program that the programmer intends to write will be doing and how even the results will be displayed. Another example or alternative is to have it as begin, then pi equals to 1.43. Print, enter radius, input radius. Assign the value of 2 times pi times radius to perimeter. Then assign pi times radius to area. Then assign perimeter to the memory location called P. Assign area to memory location called A. Then print the value in P. print the value in A, and then you end. That's another variation of the same pseudocode like the one we have already seen. The following is another example. A class teacher of Form 2A in EMELISWAP Girls Secondary School has asked you to design for her a program that would help her to do the following. Number one, accept a student's admission number, student's name, KCP marks, and the marks attained in the following subjects: English, Kiswahili, mathematics, science, and civics. Number two, the program should then calculate the subject's total marks, student's mean score, student's mean grade, and give out the comment as it is in the following table. Mean score, grade, and comment. Whoever gets mean score between 80 and 100 should be assigned grade A and the comment be excellent. Anyone with a mean score of 60 to 79 being graded as B and receive the comment good. Anyone with mean score between 40 and 59 be assigned the grade C and the comment B, average. Whoever gets mean score between 20 and 39 be assigned grade D and receive the comment poor. Anyone who gets between 0 to 19 as mean score be assigned grade E and receive the comment fail. The program, number 3, the program should then display each student's admission number, KCP marks, name, total marks, mean score, mean grade, and the comment. So this is how such a pseudocode would look like. Begin, write, enter the student admission number, KCP marks, name, English score, Kiswahili score, mathematics score, science score, and civics score. Then read admission number, KCP marks, name, English, Kiswahili, science, and civics. Then add the value scored in English, Kiswahili, mathematics, science, and civics, and assign that result to total marks. Then divide the total marks gotten by 5, because those are 5 subjects, and assign the result gotten to the mean score. After getting the mean score, if mean score is greater than or equals to 80 and it is less than or equal to 100, then assign A to the mean grade and excellent to comment. Else, if the mean score is greater than or equals to 60 and the mean score is less than or equals to 79, then assign grade B to mean score and good to comment. Otherwise, if mean score is greater than or equals to 40 and it is less than or equals to 59, then assign grade C to mean grade and average to comment. Else, if the mean score is greater than or equals to 20 and it is less than or equals to 39, then assign the mean grade D to mean grade and poor to comment. Else, assign E to mean grade and fail to comment. After that, display or write admission number, KCP marks, name, total marks, mean score, mean grade, and comment attained. Then end the program. So this is an example or another very good example of a pseudocode. My dear students and the rest of the learners, you can see that this example indicates very well that pseudocode is composed of English-like statements, with each statement expressing what is supposed to be done. And these statements are listed in a logical sequence that is supposed to be followed from the beginning to the end. Another example, number 3, is if an academic officer at EMELISWAP Secondary School was requested by the school principal to design a program that would help her do the following. Number 1, enter the student name or names and film balances for only 50 students, whereby if a student had a film balance exceeding Kenya shillings 2,000, the program would not allow any subject marks to be entered, and therefore it displayed only the student name and a comment, no marks. Number 2, if a student had a fee balance of Kenya shillings 2,000 or less, then the program would perform the following tasks. Number 1, request for marks obtained in English, Kiswahili, and mathematics. Then calculate the total and average marks for each student. So, depending on the average marks attained, the program will then assign comments as follows. If anyone gets between 80 and 100 as the average mark, the comment be excellent. If anyone gets an average mark between 60 and 79, he or she receives the comment good. If anyone gets average mark between 40 and 59, he or she receives the comment fair. If anyone gets between 20 and 39 average mark, he or she receives poor. And lastly, if one gets between 0 to 19 as the average mark, he or she receives the comment fail. Number 3, the program will then display each student's name, total marks, average mark, and the comments. So, we can write down an algorithm that shows the design of the program that I have already explained using a pseudocode. As follows. We have start, and then because we are beginning, we must begin or start calculation or computation from a certain number of students, we set the number of students to 0. And then we repeat the following activities. 1, write, enter student's name, and then the student name is keyed. The next statement is supposed to be enter the student's fee balance. Why? Because the fee balance will determine whether the next or the rest of the computation will succeed or not. So the fee balance is the one which is being used to dictate the sequence or the flow of the next instructions to be executed. So the balance is read. Then based on the balance, the necessary actions are undertaken. For example, if the balance entered is greater than 2,000, then the program is supposed to display no marks. Otherwise, if the balance is less than or equals to 2,000 shillings, then the program is supposed to request the teacher to enter marks obtained in English, Kiswahili, and mathematics. Read the scores entered in English, Kiswahili, and mathematics. Then tabulate the total or compute the total for the 3 subjects, English, Kiswahili, and mathematics, and assign the results to total marks. and then get the average of the marks entered by dividing the total marks by 3 and then assigning the result to average marks. Once the average marks have been computed, if the average mark is greater than or equals to 80 and it is less than or equals to 100, then the program should display the comment excellent. Otherwise, if the average marks are greater than 60, greater than or equals to 60, and average marks are less than or equals to 79, then the comment should be good. Otherwise, if the average marks are greater than or equals to 40 and they are less than or equals to 59, then the comment is fair. Else, if the average marks are greater than or equals to 20 and average marks are less than or equals to 39, then the comment is poor. Otherwise, display the comment fail. Now, by the look of this program, my dear students and the rest of the learners, this pseudocode or these statements are very close to the way they are coded in Pascal. Once that computation is done, then the name of the students, the total marks attained, average mark, and the comment are displayed on the screen. Then the number of students are incremented with 1. In other words, after you are through with one student, the program should move on to the next student. So if the first student was student number 1, then the program has to move on to the next student, who is student number 2, meaning it is the first student and 1. And then assign that value to the number of students. This process is supposed to repeat until the total number of students tabulated or computed is equals to 50, because this class is supposed to have maximum of 50 students. And then once that calculation is done, we stop. So that's the pseudocode for such a problem. Let's now look at the third method of developing pseudocode, not pseudocode, but the third method of developing an algorithm, which is use of flowcharts. Flowcharts are used to represent any well-defined sequence of activities. They are used to convey in a diagrammatic form the logic, processing operations, and the flow of control required of a computer program. Flowcharts are used by programmers in 2 main ways. Number 1, to plan the structure of a program before it is written. Number 2, to describe the structure of a program after it has been written. Unlike a pseudocode, which expresses ideas in form of short statements, a flowchart does the same, but using both statements and special symbols that have specific meaning. Some common symbols used to draw program flowcharts are: number 1, we have ellipse. It denotes the beginning and the end of program algorithm. So whenever you are starting an algorithm using a flowchart, you have to begin with an ellipse and we end with an ellipse to indicate the beginning and the end of the flowchart. Number 2 is parallelogram. It is used to denote an input or output operation. Therefore, whenever you have an input or an output operation to be executed, it should be illustrated using a parallelogram at the specific point within the flowchart. Example is when we have statements such as read, print, or write. The third symbol is called rectangle. It is used to indicate that a processing activity or data transformation is taking place. For example, add A to B and assign the result to Sam. In other words, pick the value entered and stored in memory location called A, add it to the value stored in memory location called B, and assign that result to the memory location called Sam. The other symbol is called rhombus. It is used to specify a condition. It's a diamond shape that shows where a decision or a test is to be made between two alternatives. The next one is called a connector. It is used as a connecting point or interface for arrows coming from different directions. Then we have the arrow, which is used to indicate the directional flow of program logic. So the flowcharts are very useful when programming because they allow the programmer to set out in a simple way the sequence that he or she wants for each line of the program. The two main types of flowcharts, therefore, are number one, the system flowchart. It is also called data flowchart. This is a diagrammatic representation that describes the flow of data through a complete data processing system. Different graphic symbols represent the clerical operations involved and the different input, storage, and output equipment required. Although the flowchart may indicate the specific programs used, no details are given on how the programs process data. It's only subsystems or major elements are shown. Number two, or the second type, is program flowchart. It is used to describe the flow of data through a particular computer program, showing the exact sequence of operations performed by that program in order to process data. Different graphic symbols are therefore used to represent data input and output, decisions, branches, and subroutines. The following are the main guidelines for drawing a flowchart. Number one, there should be only one entry or starting point and one exit point of the program algorithm. Number two, use the correct symbols at each stage in the flowchart. Then number three, the logic flow should be clearly shown using arrows. Number four, try to keep logic flow from the top to bottom and from left to right. Number five, use connectors to reduce the number of flow lines. Number six, add notes if necessary, but don't clutter the diagram. Number seven, the lines should ideally be vertical or horizontal. Avoid the crossed flow lines. Number 8, be as neat and tidy in drawing as possible. What are the main advantages of a flowchart? They include a flowchart gives the programmer good visual reference of what the program will do. Number 2, it serves as a program or system documentation. Number 3, it's easy to trace through from the start to find the action resulting from a set of conditions. Number 4, it allows programmers to test alternative solutions to a problem without overcoding the program. The main disadvantages of flowcharts include, number 1, there are so many different ways to draw the flowcharts. Secondly, it's difficult to remain neat and uncluttered if the logic is complex. Number 3, constructing a flowchart is time-consuming, and especially in cases where you want to develop programs to solve many problems. Or in other words, it becomes complex and consumes a lot of time when developing or designing a program that will solve a problem that engages or involves many stages or many activities. Number 4, they take up considerable space. Number 5, they are difficult to amend without redrawing. The following are therefore flowcharts for the 3 pseudocode examples that I've already illustrated or explained. The first one is a flowchart for indicating how the program will calculate and display the perimeter and the area. Note, every flowchart must have the title. That is an heading which briefly gives an overview of what the flowchart is intended to do. And as you can see, my dear students and the rest of the learners, is that I have included very brief statements within the symbols that I've already explained. So we have start, and that's a symbol for start. Then we have assign 3.143 to pi. From there, move on and request or prompt for the radius. Then compute the perimeter by multiplying what has been entered as radius to pi and 2, and assign that result to perimeter. Then compute the area by multiplying the value entered by itself and then by pi and assigning the result to A. And then we display, that is, we print out the perimeter and the area and we stop the operation. That's how the flowchart will look like. The next flowchart is the one which indicates how we are going to calculate and display total marks, mean score, mean grade, and the comment for the pseudocode that I've already explained. My dear students and the rest of the learners, you can see that this one is a little bit more advanced than the example that I've already shown you. The reason being, in this program, there are various activities or alternatives that will be taken based on a certain value. For example, we have the start. Then we are prompting the user to enter the student's admission number, KCP marks, the name of the student, and the scores attained in English, Kiswahili, Science, and Civics. From there, we have the computation symbol. We calculate the sum of the 5 subjects, and we then compute the mean score for that student by dividing the total marks gotten with 5 or by 5. Then we take various alternatives. We display various meaning grades and various comments based on the mean score that has been attained. We call these control structures. So if mean score is greater than or equals to 80 and less than or equals to 100, then compute or assign mean grade as A and excellent as comment. Otherwise, if that is not the case, find out whether the mean score is greater than or equals 60 and less than or equals 79. If that is the case, then assign meaning grade B to meaning grade and Gun to comment. However, if the mean score is neither greater than or equals to 80, nor less than or equals to 100, and at the same time it is not greater than or equals 60, nor is it less than or equals 79, then check whether that mean score is greater than or equals 40 and less than or equals 59. If that is true, then assign meaning grade to C to meaning grade and average to comment. Otherwise, if that's not the case, then find out whether the mean score is greater than or equals 20 and it is less than or equals 39. If that is the case, then assign D to meaning grade and poor to comment. Otherwise, if none of those scenarios are true, if none of those mean grades are correct or mean scores are correct, then assign whatever the student has gotten an E to meaning grade and fail to comment. Then, my dear students and the rest of the learners, because this flowchart cannot fit within the same page or the same screen, we use connectors and we assign a connector to each of the arrow or each of the paths. And if there are several, you label them so that when you move on to the next page or next screen, each of the arrow can be guided by its respective connector. So in this case, I have labeled my connectors as A for that path, B for the other path, C for the other path, D for the other path, and E for the other path. Let's now see what will happen on the next screen. So when you move on to the next page or next screen, you repeat the same connectors. You label them in the same manner for connection so that the reader can be able to see the flow, can be able to follow, for example, the path for connector A up to the end, the path for connector B, the path for connector C, D, and E, respectively, up to the end. So all those connectors have now been joined together, and then we move on, regardless of the path that you follow, or regardless of the mean score that has been attained. At the end of the day, the program is required to display the student's admission number, KCP marks, the name, the total marks, mean score attained, the mean grade assigned, as well as the comment. Once that is displayed, then we end our operation with stop. So that's how we can draw a flowchart, and more so those flowcharts that are advanced and that cannot fit within the same page or the same screen. The third example was the pseudocode that was used to calculate and display student marks, total marks, average mark, and the comment, but for only 50 students. So the flowchart for that pseudocode would be as follows. Just as it was for the previous case, then even for this situation, the flowchart cannot fit within the same page, and therefore we have to use connectors. As you can see, we have 3 connectors. We have connectors A, B, and C. So from this flowchart, we begin at the starting point. We assign a 0 to the number of students. And then from there, we prompt the user to enter the student's name and the fee balance. Then we check whether the balance is greater than 2,000. If that balance is greater than 2,000, then we display the name of the student and we don't do any calculation for the results. And therefore, the message to be displayed is no marks. However, if the student's fee balance is not greater than 2,000, meaning this student is now qualifying to sit for the examinations, then we prompt the user to enter that student's score in English, Kiswahili, and mathematics. And then once that has been done, my dear students, you can see, and the rest of the learners, you can see that we also have connectors, and we use them just as I have explained. So the pathway for the path B, for connector B, will proceed, and we are going to compute the total marks by getting the sum of the 3 subjects, and then we divide that sum by 3 to get the average marks. And then because we are supposed to display the comment based on the average mark attained, then in that case, we have several options. The first option is to check whether the average mark attained is greater than or equals to 80 and it is less than or equals to 100. If that is true, the program is supposed to assign the comment excellent. But if that is not the case, we then move on and find out whether or check whether the average mark attained is greater than or equals 60 and it is less than or equals 79. If that is true, we assign that student the comment good. But if that is not the case, then we confirm or find out whether that average mark gotten is greater than or equals 40 and it is less than or equals 59. And if that is true, we assign that student the comment average. Otherwise, if still that's not the case, we find out whether the score or the mean score attained or the average score attained by the student is between or is greater than or equals to 20, but less than or equals to 39. If that is the case, we assign that student the comment poor. However, if the student's average mark does not fit within the range already checked from 100 to 20, meaning it is less than that, then we assign that student the comment fail. Once that has been done, then we join all the pathways and display the student's name, total marks, average, and the comment. And lastly, we increment the number of students to the next student with 1. So if you are handling the first student, it is 0 plus 1. That gives 1. When you are through with the first student, then you repeat the same operations for the next student. So to move to the next student, the program has to increment the first or the value it was dealing with to the next value. So if it was 1, student 1, the numbers be incremented with 1, giving 2. So we handle student 2. If the current student being handled was student number 2, then to move to student number 3, we increment the number of students we are dealing with, that is 2. We add 1 to move to the next student. And as that continues, we always check whether the number of students we are dealing with are equal to 50, so that once we get this number of students to be 50, and we check the situation and realize that we have already handled the 50th student, then we stop the operation. Otherwise, we continue repeating those operations for as long as the number of students do not exceed 50. And that's all with that flowchart. And that's how you interpret the flowchart of this type. The following are therefore some examples of programs written using Pascal in the pseudocodes or for the pseudocodes and the flowcharts that we have already designed. The first program is for calculating and displaying perimeter and area of a circle. In other words, we are now translating the pseudocode or the flowchart that we have seen into a specific program using a specific programming language, which is Pascal. So, following the syntax of Pascal, we move around this algorithm as follows. We write the pseudocode for that algorithm as follows. 1, keyword program. The name of the program is circle. Then we declare a constant called pi, or a memory location called pi, that will hold 3.143, and that value will not be changing during the program execution. So that's how we do it. From there, we declare variables, memory locations whose content will be changing as the program continues being executed. And these variables are R, P, and A, and they are going to hold data of type real. That means data that has fractions or decimal points. Once we have done that declaration, we begin the body section. And we have the following instructions. And my dear students and the rest of the learners, kindly note the syntax. And for you to get more information about how we write program in Pascal, kindly visit EMELISWAP ICT YouTube channel and look for the video by the title Elementary Programming Principles with examples using Pascal, part 1 of 4, where I discussed in depth about how we write a program in Pascal. So right line, enter the radius of the circle. Ring line, R. What this means is that we are going to pick, or the compiler is picking, or the processor will pick the value entered by the user and assign it to a memory location called R. From there, we calculate the perimeter and the area of the circle. That is how we comment in Pascal. The comment here is perimeter. This instruction or this statement is for computing the perimeter of a circle. And that is, pick what is in memory location called R. Multiply with what is stored in the memory location called pi, and whatever you get as the results, multiply by 2. Then the total results gotten, assign them to a memory location called P. So that's an assignment statement. Assign the results of 2 times pi times R to the variable or the memory location called P for perimeter. Then compute or pick what has been assigned in memory location called R, multiply by itself and by what is stored in memory location called pi, and the results that you get, assign them to the memory location called A. And that comment there indicates that that statement is for tabulating the area. Then the next comment is we want to display the perimeter and the area of the circle. And therefore, we have the statement, right line, the perimeter of the circle is, pick what is in the memory location called the P and display after that statement. Then, right line, the area of the circle is A. In other words, display the message, the area of the circle is, then pick the value stored in memory location called the A and display it on the screen and move on to the next line. And that's the end of that program. We end. So that's how we write a program in Pascal for calculating and displaying the perimeter and the area of a circle, whose algorithm I have already explained previously in this presentation using a pseudocode and a flowchart. Let's move on to the next example that I've already used. The following program is for calculating and displaying the total marks, mean score, and mean grade attained by a student. As usual, every program in Pascal begins the program header, program, followed by the name of the program. And I have said before in my previous presentations that let the names of our programs be user-friendly. Let's know what that program is dealing with. This program of mine is dealing with the marks. Then we declare certain variables. The first one is CRT, what we call uses. And the comment here is to enable us to be able to clear the screen. Then we set memory locations assigned for storing string data type. And these memory locations are name and the comment whose content will be changing. That is variable. And the other one is memory location called meaning grade, which will contain characters or a character. And then we have memory location called animation number, KCP marks, English, Kiswahili, math, science, civics, and total marks, which will hold values that contain whole numbers, that is integer. Then we have a memory location set aside called the mean score, which will hold data that has decimal point or fractions. Once we have done our declarations and we have set our memory locations assigned, and we have specified the type of data each of them will hold, then we move on to the body of our program. And we have begin, then right line. Enter students' animation number and KCP marks. That statement will be displayed on the screen, and the cursor will wait to read the score on the next line. Therefore, the user will key in admission number, press enter, and the key marks, and press enter. Whatever will be entered will be stored in memory locations called admission number and the KCP marks. Then the user will then be prompted again to enter the name of the student, and he or she will type the name and press enter. That name or that value which will be entered there will be stored in the memory location called the name, and the cursor will move on to the next line and wait to read the next value. So the next statement is right line. The following statement will be displayed on the screen. Enter the student marks for English, Kiswahili, mathematics, science, and civics. Then the user, guided by that statement, will key in the scores attained by the student in English, Kiswahili, math, science, and civics. Those values entered as the user presses enter key will be assigned in each memory location in the order listed. The first value will be stored in memory location called English. The next one in Kiswahili. The next value will be stored in math. The other one in science. The other one in civics. And the cursor will move on to the next level on the screen. From there, we are computing the results. That's how we comment in Pascal. How do we compute? So we have total marks equals to, that is an assignment operator, English plus Swahili plus math plus science plus civics. You terminate with a semicolon. What that statement means, or this is how it is read, that we are telling our processor to pick the values stored in memory locations called English, and to what is stored in Kiswahili, then and to mathematics, and to science and civics. In other words, compute the sum of the scores entered and stored in the memory locations called English, Kiswahili, math, science, and civics, and assign that result to the memory location set assigned by the name total marks, which we have already declared at the declaration section for variables. From there, the next statement reads, pick the value stored in the memory location called total marks, divide by 5, and store that mini grid or that result to the memory location set assigned and given the name mini score. Then from there, we compute the mini grid and the comments. So we say if mini score is greater than or less, is greater or equals to 80, and it is less than or equals to 100, then begin or do the following. 1, assign A to the memory location called mini grid, and excellent to the memory location called comment, and stop there. Otherwise, if mini score is greater than or equal to 60 and it is less than or equal to 79, then do the following. Assign B to memory location called mini grid, and good to the memory location declared and set aside as comment, and end there. Otherwise, if the mini score is not between 100 and 60, then check if the mini grid or mini score is greater than or equals to 40, and whether it is less than or equals to 59. If that is the case, then do the following. Assign C to the variable location or to the memory location. To the memory location called mini grid, and assign the comment average to the memory location set assigned and called comment. Otherwise, if the mean score is greater than or equals to 20 and it is less than or equals to 39, then assign character D to the memory location set assigned by the name ingrained and put to the memory location set assigned and called comment. Then stop there. Otherwise, if none of those scenarios are correct, then assign meaning grade E to the memory location called meaning grade and fail comment the memory location set assigned and given the name comment and stop. Finally, display the admission number, the KCP mark, the student's name, the total marks added, the student's mean score, student's mean grade, and the comment on the screen. Then pause a little bit for the reader to read that information and stop the computation. So that is another program in Pascal. Then the last example is the program for calculating and displaying students' total marks, average mark, and the comment for 50 students. So the name of my program or my program handler is program averages. We declare or set aside memory locations that will hold value which will be changing, that is variable, and we give them the name and the comment, and the content to be held there or the data type will be string. Then we also declare the variables or memory locations called balance and average marks that will be holding values within decimal points or fractions. Then we also set other memory locations aside for holding values that do not contain any fractions, that is whole numbers. And these memory locations that we are setting aside will be called total marks, months, Kiswahili, English, and number of students. From there, once we are done with declaring our variables, as you can see, we are going to move on to the body of the program. And we have, first of all, the first statement is initializing or setting the memory location called number of students to 0, so that if there's any previous content that was there by default at declaration will be erased. And then we shall be able to carry out our computational calculation commencing on a clean slate or a memory location that does not contain any value except 0. Then we repeat the following steps. We request the user to enter the student name. Within that name, or the processor will read the name. And then after reading the name, that name or the value entered will be stored in the memory location called name. And then it will move on to the next statement or next level on the screen and request the user or display the statement, enter the fee balance. The user will then key in a value which will be picked by the processor and be assigned in the memory location set assigned called balance. And then we shall move on to the next statement or next step. The next steps involve checking if the balance is more or less than 2,000 and then performing the computations. That is how we comment in Pascal. Commenting or comments within a program or within the source code is very good because it encourages a programmer or a reader to be able to know what is happening at each point. So we check if balance is greater than 2,000, then just display the student name and the message no marks. Otherwise, if the balance is less than or equals 2,000, then do the following. 1, request the user to enter marks obtained in English, Kiswahili, and mathematics. So the reader or the user will key in the score for English. Press enter. That value will be picked and stored in memory location set aside by the name English. Then he or she will key in another value. That value will be picked and stored in memory location set assigned by the name Kiswahili. And lastly, he or she will key in another value and press enter, and that value will be picked and be stored in memory location set aside by the name months. From there, the processor will compute or calculate the totals. It will pick or find the sum of the content stored in the memory location called English, Kiswahili, and months, and assign that result to the memory location set assigned by the name total marks. Then the compiler will tabulate the average score by getting the content stored in memory location set assigned by the name total marks, divide by 3, and then assign the result in the memory location set assigned by the name average marks. Then from there, the compiler will compute, or the processor will compute the comments based on the average mark gotten. So if the average mark gotten is greater than or equals to 80 and it is less than or equals to 100, then assign, or the processor will assign excellent to memory location set assigned by the name comment. Otherwise, if the average mark is greater than or equals 60, but it is less than or equals 79, then the processor will assign the word good to the memory location called comment. Otherwise, if the average marks are greater than or equals to 40, but they are less than or equals to 59, then the processor will assign the comment fair to memory location called comment. Otherwise, if the average marks are greater than or equals to 20 and they are less than or equals to 39, then the processor will assign the comment poor or the value poor to memory location called comment. Otherwise, if none of those situations are correct, then the comment fail or the value fail will be stored in memory location called comment. Lastly, the program or the compiler will display the name, the total marks, the average marks, and the comment for that student on the screen. And then from there, increment the value of students with 1 so that it is able to move on to the next student. That's why this statement reads, pick the value in the memory location called number of students, add 1 to 8, then assign the results gotten to the same memory location called number of students. In other words, this is an assignment statement or assignment operation that replaces the previous value in the memory location called number of students. So to pick what is there, increment with 1, and write the value, the new value, back to the memory or to that memory location. And that will continue until the number of students is equals to 50. And then that is the end of the program. And with that, my dear students and the rest of the learners, we have come to the end of part 3 of 4 in this presentation, and you can now proceed to part 4 of 4 on program control structures. Congratulations for learning part 3 of 4 in elementary programming principles topic. You can access part 1, part 2, and part 4 of the topic, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to this channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and God bless.